Hi, I am Tamir, and in this video I'll show you how to make this. A flexible LED panel, which is bicolor, can go from tungsten to daylight, can be dimmed from 0 to 100 on each channel. It's also very lightweight, it's only weight 200 grams, and the best thing about it is that it only costs about $100 to make. And also wonderful concerning color rendering. It's 85 plus in the CRI. And you might say it does look familiar, and you're right. The design is being taken from design that I saw online. Matt from D.I.Y Perks did it. I took the same design, upgraded a bit, fixed a few problems I encountered in his design during the way, and this is the results. Basically, it's the same, only that it's being powered by the electricity or by a 12-volt battery. And the dimmer is a different one. I encountered a problem with the dimmer. He suggested that it didn't hold the load, and therefore I looked for an alternative and found this solution. So without further ado, let's see the video. For this build we need 2 strips of LEDs, every strip coming on a roll which is about 5 meters, which will be enough for this build. You'll have links in the description below for what I've chosen. One is basically in the color temperature of 32,000, which is tungsten, and the other one is about 6,000, which is daylight. Both of them have a very nice color concerning the CRI value, as I mentioned before, and therefore they are wonderful for video and stills. Here you can see them being powered from a 12-volt battery, which is not full, so therefore it's very dimmed, as you can see. We'll start by cutting the wire that came with the strip, as we don't need it, and then we'll put the strip on a ruler, and about 30 centimeters length, that's the place we need to cut. As you can see, I'm cutting in the place which is marked with scissors on the strip itself, exactly in the middle, so we can easily solder out the wires afterwards. Continue on this process with both strips in both color. Eventually we'll end up with 16 strips from each color temperature. So after we have 16 from each color, we can start our build. In order to do it, I found that false leather will be a wonderful material. Of course you can choose whatever you want, but this will be wonderful for this build, as it's rather cheap and easy to work with. So we'll start by cutting from a big sheet a square of 32 centimeters by 32. Of course we can take the scissors and cut it out. As you can see, I'm doing it right now. Now we'll make an internal square, which is 6 from each side and 5 from the top and the bottom. This will give us the place to place the LED strips, so they will be in the center of this false leather. Now I found that the Polymax material, which is a silicone-based tube, is the best for doing this job, although the LED strips coming with a sticky in the end, still it's not good enough for this false leather. And of course, when working this material, I recommend you use gloves because it's sticky and it's not so comfortable to work with it with your hands. So in this way you don't need to clean your hands after every spill or something you have with the material. Although you can definitely work without the gloves, but found it very easy. Now in order to peel out the double face of the LED strip, I used a knife here, as you can see, to easily take it out, especially when you're working with gloves. It's necessary because otherwise it's very hard to take it out. You should pay attention to the polarity. There is a plus and minus marked on the LEDs, although it doesn't important to which side you'll put it, but please pay attention so all of them will, all the strip of course, will be in the same polarity, meaning the plus will be in the top or the minus will be in the bottom, but at least all of them need to be in the same order, otherwise it will be very hard to wire them up. And so basically you put a very small amount of silicone from this tube, and then you press the strip itself to the false leather, as I'm showing here, and of course repeating the step now with the second color strip. So the first one will be the tungsten based, and the second one will be of course the daylight, and so on. And we're repeating this step until all of the false ladder is filled with the LED strips. Again, with the knife, taking out the double-sided tape, very easy as you can see. Looking at the polarity and continue to put them in place. After finishing this build, I'm going to put some weight on it so it will press down the LED strip with the silicone to the false ladder so it will stick the best. In order to do that, I'm putting half of shelves that I have lying around, and above it some jerrycan of water to add an extra weight. I have left mine overnight just to be sure, and as you can see, even if I bent it and roll it, everything is sticked to the false ladder. Next stage will be to take the solder paste, that's the trick here, and apply it to the contacts of each LED strips. Of course, we are doing it in one side for one color and the other side will be the other color. And the whole idea here is to put a bit of solder on the contacts that will allow us afterwards to make the connection very easily. Without it, it will be a bit of a problem. I think this is one of the stages no one show you in any movie I have at least seen for doing this stage. Everybody is passing by this, and if you don't do it now, afterwards you cannot, no way you can put the wires to it. So we're taking 60 centimeters wire. This is basically 1.5 millimeter wire, electricity wire. We need, of course, 2 from the red for the positive and the same 2 for the negative, which is the minus, of course. So again, just measuring 60 centimeters long and cutting them down. We'll take this exposure wire device and we'll use it in order to expose the wires. I'll show you exactly how I'm doing it. Basically, I'm taking a bit of wire that I'm going to take out, the insulation. It's about 8 centimeters from the start, and the first stage will be to take it out. As you can see, I'm doing it right now. Next stage, of course, is to take out the insulation and just move it all the way to the start. But not entirely, so it won't get out. And we're repeating the same step over and over until we'll have places that the wire is with no insulation, and of course the insulation is in between. After that, I'll show you exactly why we did that. So we'll repeat, and in the end we'll have a wire that we need to cut, so basically we cut it out. Repeat the same step again, 8 centimeters from the start, and taking the insulation out, doing it the same. I will mention that this video, although it looks very long, it's been shortened down. I basically cut out all the steps that are repeating themselves. So you won't need to see myself doing it again and again and again. Of course, when you'll build it, you'll need to do it, but I didn't want to take any part of the build out, so you won't miss anything that you need to figure out by yourself. and therefore if there is steps that need to repeat themselves, of course I'll tell you, and you will see me doing only once. Again, in the end I'm cutting the wire that I don't need. So we'll end up with wire that look like that, with a place that is exposes and place where the insulation is in. Eventually it's 16 points that we can connect it. Again, putting it in the paste and soldering the end. That's how we start here. Now the next step will be to bend this wire in this way, as I'm showing you now, so it will fit our LED strips. Basically you just bend it with your hands, and since it's very flexible it's not a problem, and in the end we'll end up with something that looks like that. Now we'll start soldering it to the LED strips, and as we did solder a bit of solder iron before, it will be very easy to catch the wire now. And as you can see, this task is very easy to do since we did the preparation before. Of course I'm soldering it the positive to the positive, as you can see. That's where the red wire is going to the positive, and the black one of course will go to the negative point. Started with the negative, the black wire, doing the same task from the other end to the start. Doesn't matter from when you start. As I mentioned before, I'm only showing you this task in one of the sides. This is the daylight, and of course afterwards you need to do the same in the other side of the LED strip for the other color. The next step will be to take a wire which has internally 4 wires, 4 times 1.5 millimeter. It's basically like an extension cord, only with 4 wires and not 3. And I found this to be the right wire for this job because it's the same thickness as everything that we are using, and it can hold the current that this unit will need. Later on in the video I'll show you exactly what is the amount of current each color temperature is taking. For now, again, we're taking the knife and we're taking out the installation of these wires. We need to take a bit of them and then so we can use it in this build. Now of course I'm marking in the center of it, which is 21 centimeters, a place where I'll make a hole with a knife for the wires, of course, so it can go inside, as you can see here, very easily. Just cut a small hole, and from there we can insert the wire. Now, in order to hold the wire in place, of course I'll take the strips and make a hole in each side of this wire, so we can put that inside so that it will hold the main wire in place, so it won't move in case somebody will trip on it. And so this is how it's been done, putting it from one side and let's go from the other side, and eventually holding the main wire in place. So now we'll take the wires to the middle of each build, and we'll cut an extra, take the exposing the wires and solder them down to the plus and minus of each strips. We'll repeat the same step in the other side, in the other color temperature. So this is how it's been done. Now it should look like that. Next task will be to take the side of the false ladder and fold it down as I show you here, and to the point that it's covering the wires. We'll do the same in the other side, and we'll mark it with a marker here, and the same thing in this side. So in the end we have some sort of a corner is marked on the false ladder, again as you see here. Now we'll take our ruler and measure 6 centimeters from the corner we just did, as you can see, and we'll put a mark in the end, and again the same thing on the other side, 6 centimeters, and mark it. Second stage will be to take a knife, and we're going to cut this place. So we have, as you can see here, just cutting it on the line to the point of the 6 centimeters. And this is how it should look. Now we'll take again false ladder with a size of 10 by 10 centimeters. We need 2 squares, cut them in the middle. So we end up with triangles, as you can see. Now after we have the 4, we'll mark, as you can see, 4 centimeters from that point, and we'll then cut the rest that we don't need. Do it once, then taking the second one, putting it over the one that we just cut, and repeating the same cut to all the 4 triangles. Now we'll take one and put it in the corner that we cut before. As you can see here, we'll take our silicone based glue and put on each side a fair amount of silicone, and this will act as our glue. And we'll take the knife to put it in place. Now I decided to add some super glue so it won't build up, especially when it's taking its time to dry. Basically the first dry will be after 4 hours, and eventually after 24 it will be totally dry, even if you put a lot of silicone inside. And as I told you, I'm only showing it once. You need to do it on all 4 corners. In the end, this is the results. We have some pocket. As you can see, this unit doesn't have anything to hold it, so we'll need a wire to make it stronger so it can hold itself. We're basically cutting, it's a garden wire, which doesn't have any insulation on it. Concerning the thickness of it, it's about, I think, 2.5 millimeter, the same as every electric wire that people use. Only doesn't have any insulation on it, and it's sort of an aluminum wire. Doesn't have to be, but this type is a bit stronger than the regular wire that you use inside. And then we'll make some square, tape it with electrical tape so it won't move. And after that I'm adding super glue and of course our silicone in order to glue it to the false letter. This is the tricky part. It's one to jump all the time. So I eventually managed to glue it again with super glue and putting some weights on it so it won't get up. And then you can do that. This step looks easy, but it's one of the steps that takes time. And again, to put some tapes on the lead strip so when we're going to put the silicone it won't go above them. Again, I found it in the end not necessary because if you put in it right you don't need it. And here I can show you that I'm testing the LEDs to see that everything's working with a 12-volt battery before I'm closing it. So I won't need to, after I close it, to find out that I have problems. So again, taking the two wires, the plus and minus, connected to a battery. As you saw, it wasn't very hard light because this battery is almost empty, so it's basically giving about 8 volts. This is wonderful for this type of test, as I don't need to be very bright for the test. Now I'm putting a lot of silicones in both ends, and of course after that in the other two, tops and bottom, and of course closing the false letter so it will cover the wires. As you can see in here, after I put a lot of the silicone, I still saw that it didn't catch everything, so I needed to add more. So I took out the tape and added more silicone, so it will be filled with it. And this is acting as an insulation and also as a glue, and all in the same material, so it's wonderful. And this is the strongest again I could find concerning silicone, which is also a very hard glue. Next step will be to put some weight on it. I'm using, as you can see here, 12-volt batteries, also the same kind I will use for this light. This one particular is dead, but I'm using them as weights, which is wonderful for this task. And again, after this sits, I'm putting silicone on the other side and repeating the whole step until this whole build is closed and look as it should in the end of the work. After that, I let it sit for about 4 hours, so the silicone will dry a bit. I'm taking out the batteries, and as you can see, it's holding. Now it's time to do the second step, to glue the top and the bottom of this unit. Again, the same thing, I'm just leaving the corners. I will address them a bit later. So for now, as you can see, they are stayed unglued and open. And we're repeating the same step here by folding it down and putting weights on it so it will stick. Concerning the corners, as you can see, we end up with that type of shape. We'll basically take scissors, cut them in the middle, so we end up with that. Now we'll trim it a bit so it will fit nicely, 45 degrees from each side. This is how it's been done, again very easily. And after that we'll put silicone, of course, inside to glue these corners. So we'll do it for this corner. We'll put the silicone and we'll close it, and then we'll do it the same on the other end, the second corner as well. After we finish that, we are going to do the place where the wire is coming up, as you can see here. Again, the same method, only here you need to put the wires in place. Working with gloves is recommended, as I said, so you can easily continue to work. You don't need to scrub your hands because the silicone is not nicely. And again, if you have too much silicone, easily with a knife, as you saw me doing, you can take out. Not a problem. Again, putting weights so it will hold. Now, as I promised, here is a small device. It's a power meter. It's showing you the current, the voltage, and the amps this unit takes. Now I only connected one channel, so this is the tungsten version, 4.78 amps, and here you can see the daylight one. Again, the same amount of current being taken from the unit, and this is connected now to the power supply that eventually will feed this unit. Here is all the tools you need in order to make the continuous of this build. I took an electrical box which are 20 by 15 by 8, as you can see here. It's very standard here. Just open it. It's coming with a nylon case to protect it from again, dust and everything. And here are the measurements you need to make. Basically, it's a point for 4 holes, 2 for the potentiometers of the dimmers, and 1 for the switch and 1 for the LED that are indicating that we have power for the power supply. And I'm drilling it now with a 6mm drill, and now as you can see I'm using a conus one to make this hole fit the on-off switch and also the LED light indicator that is rather big. It's 22mm in diameter. Again, putting the place for the connector for the LEDs, as you can see the measure before. And again, drilling it with the conus. And as you can see, it fits nicely. Now we'll drill from the other side. This is the measurement, 3.5 centimeters by 2.5. This socket will be for connecting the 12-volt battery, so we can feed it as well from a battery and not only from the electricity. Again, putting the socket here and connect it. Next stage will be to put the hole for the vent shaft in each size. This is the measurement. And for that we'll use the next tool I'm showing you. Again, this has been done with different type of gloves, as you can see, for protection, also using glasses because there are parts that can fly to your eyes. This is basically a special knife designed to cut plastic, and I'm using the Dremel tool to cut this hole. Without it, I think it will be very hard to make this hole, and since I started using this tool, it's wonderful. Eventually we have the hole, and this is the aluminum cover that I purchased in a hardware store. Again, it's something that I couldn't find online, so I'm sorry I can't provide any links, but I think you can find it in a hardware store. Since it's a bit too long, then we need to cut it out, as you can see here. And since it's aluminum, then it's very easily broken after there is a line where it should be cut. And we'll do the same in the other end as well, and of course I also need to take out this bit of aluminum that are preventing it from going in place. So again, we'll cut it and take a plier and break it afterwards. In the end, as you can see, there is some piece of it left on it, so it won't be in the right it won't be smooth, so we'll take in a paper that will be easily used as a sandpaper to sand it a bit, so it won't cut us, of course, without it. And I'm also using the Dremel tool with a different type of blade in order to, the same as the sandpaper, take out the parts that are in the way here. Again, you need to do it very gently, so you won't get into any problems, but since it's aluminum, it's very easy to do this task. Of course, we'll need to do the same thing in the other side of this box to cut the hole and this aluminum. And in the end, we of course glue them with our wonderful silicone, as you see here. Basically apply it all around the corners and put this piece into the place of the hole that we just made in the box. The whole idea is so it will have an airflow and can be cool itself without any fans inside. As I told you before, I'm showing it only from one side, and you need to do exactly the same in the other side of this box. Basically put it in place and press a bit so it will hold. Now the next stage will be to choose the power supply. The power supply I used is the one you see on the right. Although the one I'm showing you here on the left has the same spec, it doesn't hold the load. So don't buy this brand. This is how it looks. Buy the white one. This is bad. It's after 6 amps it's falling. So basically don't buy that. I'll put a link in the description below. Now the next stage will be to open it, since we don't have a place for the cover. Again, taking the Dremel tool and with the blade that are for plastic and cutting out the box of the power supply, going all around it, and this is the only way I think to open it, because it's basically glued. And again, after I turn all around it with a screwdriver, as you can see here, I managed to open it without damaging the internal power supply. Next thing will be to take it out. It's been glued with some sort of material inside, so use a screwdriver to take it out. And after it's out, we of course disconnect the internal socket that comes with it, the one for the C13. This is I'm cutting now. We'll use it in our build to put on the box that we are building. This will be our in point for the electricity, as this is a standard socket as you mainly see in computers or so. So I just marked on the box with a pen, as you can see here, and now we're going to cut it. Again, using the Dremel tool with the cutting blade. And the technique here is cut it as I'm showing you now. This is something I always wanted to learn how to do, but no one in any video I saw on YouTube show how to do it. So I'm leaving this video here so you can see exactly how you cut something like that. Basically you're doing an X and then continue cutting in any shape you can. The whole idea is that it won't cut too much, so we won't have any problem. And after, as you see here, it's very easy to do. I will take a screwdriver and break it and continue the next stage to change the head of these Dremel tools and set up the size of this hole to what it needs to be to hold this plug. Now with a different head on the Dremel tool, same as sanding, only again this head is for plastic, basically cutting it very neatly and smooth, and as you can see, after a bit of work, this fits in nicely and click inside the box. Now we'll connect the 12-volt plug, the one that we'll use in order to feed this build with 12 volt from a battery. Basically put it in its place, closing the nut behind it and tidying it up with a plier. Now I'll take the 4-pin military plug, and I didn't show you about that before, but I drilled 4 holes in the plastic of the box, and now only thing left was to put screws which fit this plug. Again, this is I think 4mm screws, of which I again purchased at a hardware store, not something I could find online, or probably it exists online, but it was easy to just go with the plug and fit something that will be the right size, putting a nut and then closing it. Now we'll put the LED indicator for the power supply. Again, this is the LED that's getting 220 volts, since this is the voltage here. Of course, if you need 110 volts, of course, just purchase the right one for you. Now we'll take the on-off switch. This is a 2-pole on-off switch, which is designed to hold about 15 amps, which is more than what we need here. Again, I'll put a link in the description below for the one I purchased. Now, in order to know when it's on and when it's off, I just use my voltmeter in the position of beeping. As you know from a lot of measuring devices, there is a point that you can basically short circuit them and you have a beep from the unit. And then this is how I discover on which size it's on and which is off, because it's not clearly written on the on-off switch itself. And again, tighten it up. Next stage will be to reopening the volt regulator. This is the 12 volt regulator that we'll use as a dimmer. This is how it's coming in a packed, in a plastic bag. Taking it out. Now we're measuring 30 centimeters of wire. Again, this is 1.5 millimeter, and a wire that has both the red and the black connected to each other, basically. And now we're going to solder it out to this part of the volt regulator. Basically, this is the 2 point we need to solder out the wire. We expose it very little and then soldering it as you see here to these 2 points, and on the other side, of course, we'll put a potentiometer that will act as our dimmer. So again, this is the potentiometer. It doesn't has any, you can connect it to any side of the legs, as long as one is in the middle and the other one can be in any side of it. It has no impact whatsoever, so just connect it how you like. Next stage will be to take out the 2 wires that were connected from the factory to feed the unit from the electricity, and I'll just change them with a bit longer wires so it will fit our box, because the wires that are left here are very short and of course we won't be able to use them. Again, I'm using the same wire, the black and the red one, the 1.5 millimeter, to supply the power from the electricity to this unit. Now, on the other hand, I'm just taking out the wires that came with the unit, and of course replacing them with a short wire that will be connected to our build. This will be the feed with the 12 volt DC, and it will be connected in the end to both dimmers and the 12 volt socket that came from the battery. Again, plus to plus, minus to minus, very easily. Do it one by one so you won't have any mistakes here, because it's not marked here at all in the back. So just take one wire and then connect the other one. I'm taking 1.2 centimeters screw, which is a quarter, and using a 30 millimeter buxa in order to close it. Now I drilled, it's a 6.5 hole in the box. This will act as our legs for the box. So I'm putting in the screw inside. In the other hand, for now it doesn't have anything, so it's just, the hole is very narrow, so it's just putting itself inside. As you can see, we're using a Loctite 270. This is specially glued for gluing metallic nuts. and screws and so, and it's wonderful for this task. And we'll take this part, which is basically female to female, which go up here, and in the other end, of course, we'll take this leg, which again all are found in a hardware store, and put glue here in this side. So again, it won't be we'll lock it in place, it won't open when this box will move on the floor, or if somebody accidentally kick it or something, the legs will stay in place. And again, I'm showing you one leg, and you need to repeat this on all four. Again, very easy task from all this build. Just turn it around and tighten it up a bit with your hands. And again, I can tighten it a bit with the wrench, just so it will be in place. As you can see, this is the end results. I have 4 legs. Now I'm taking this sticky tape, which also has a bit of sponge to it or something like that. This will cover up our screws so they won't short circuit any boards that sit inside. As you can see, very easily put it on the screws themselves, on the heads. So this acts as an insulation and also as a sticky material to hold everything in place, although of course we'll use our silicone to put all the cards stick to the box. We'll take wires, 30 centimeters, a couple of them, as you can see I'm doing here, and these wires will be connected to our switch, on-off switch, to feed the power supply. So again, I'm putting here a cover that's fitting the screws on the on-off switch and soldering them out so they will be tight to the wires. Continue this task several times because we need 2 wires as well from the input of the sockets that will be connected to the electricity to the on-off switch, and from the on-off switch, of course, to the power supply. We also need another 2 wires to give power to our LED indicator. Now, of course, we'll connect everything together. We're opening the 2 wires that you see connected already. That's the one that's giving the power to the switch. That will go to the plug that we put on the box, the C13. One will, of course, will go to the LED indicator, and the other one, of course, will go to the power supply itself. Doing the same thing with the red one, and now connecting it to the indicator LED, closing the wire, and of course we'll tie it up here afterwards with a strip, so it will fit nicely. Again, I didn't put a lot of insulation and everything because this box will be closed, so nobody can touch it, therefore there's no need. And as you can see, I'll just disconnect the wire that we soldered before and connected the longer wire that I just connected to the switch. This, of course, going from the up position of the switch. So in the bottom it's getting the feed, and in the up position it's getting the output. And now I'm connecting to the input to the switch. So this goes to our socket that will be connected with a wire to the wall, and it will give us the power from the electricity. Again, now we'll took again a wire that has the 2 wires together, and we'll cut a small amount. This will be connected to our 12-volt connector, and from there we'll connect them all to, as you can see, this will be the input for the dimmer. Again, 2 short wires only need to sit inside the box to feed the 12 volt, and I'm taking all the wires together and connecting them first by hand, and of course after that we'll solder them, so it will be a very strong connection. All there, it's going to be 4 wires all together in each color. Of course, we have 2 for each of the dimmers and another one for the input of the 12 volts. And the third one goes to the output of this power supply, which is already been soldered out, as you can see here. So all of these wires will be together, and from here we'll continue. So in order to solder them all together, I put it on a hand that holds it, and then it will be easy to put with the paste and the solder to do this job. Otherwise you need a third hand, which I don't have. So this is the solution. This is basically holding everything in place, and you can put a good amount of soldering so it will bind them all together. Now, in order to isolate them, we'll put 2 heat shrink on them, and above that we'll put another one. I just want to be extra secure here, so it won't be any short circuiting even if it gets hot. So basically we put in these 2, and this is the hot gun with blowing hot air. And again, something I purchased on eBay, unknown name, but doing the job. I think you can pick up anyone you want. It's rather cheap. And of course you can do the same task with just a fire from a match or something, but this way it's of course more professional. And as I told you, we're putting another one above the 2, so we'd hold them together. And now we are connecting the 2 wires to the plug that goes to the 12-volt battery. Again, it doesn't matter which of the 2, as long as we keep the polarity correct. Again, we can decide which one goes to each side, and connecting the other end of the wires from this whole bunch of wires to the input of the volt regulator. And this is done with screws and the connecting point, as you can see here. Now I'm connecting the outputs. As you can see, it's marked out of each volt regulator, and this of course will go to our 4-pin military plug that will feed the LEDs on our light. And again, soldering out the 2 colors, of course the daylight and the tungsten, each one to each set, of course, to a side of this military plug. I decided to go with it because it seems to be very robust and a plug that will hold abuse of connections and disconnections during this life of this panel. So it will hold and won't break, and it's also very easily to connect. So that's why I decided to go with it. And of course, in the end, it's very cheap to buy. So it's a winning plug in all scenarios. Okay, and this is the potentiometer. As you see, there is something here that we need to break, otherwise it won't sit nicely on the panel. So just breaking this part out and then plugging it to the panel and putting the gauge. Again, I'll put links to everything in the description below. It's basically giving us a gauge of numbers, so you can see from 0 to 100 where we are. Of course we can see that on the light, but it's nice to have this here as well. And we're putting the button above it. It has small screws on the end, so we just need to open it and then connect it tightly to the potentiometer. Again, doing the same task in the other one, a very simple one. I would mention now that you need to here to put the potentiometer all the way to the left and then put the button in the right place, so the 0 will be 0 and not something else. And again, after connecting both of them, this is how it looks. Now I'm cutting the wire that go to the military plug just in the right length, so it will fit the plug nicely, and of course then soldering it to the plug in the right polarity and everything. Again, putting some soldering paste so it will be easier to solder, and then soldering it to the right place. Now we'll connect the other end of this plug, and it has a opposite screwing, so it won't open. So as you can see, it's left one, not right. And after that, I'm closing the 2 screws here in the back to hold the cable so it won't go out. And I put, as you can see, the ring upside down so it will be tight, and this is how it works. You plug it in half round. Now you can see the voltage of the volt regulator input is 12.33 and the output is 9.29.5. So we need to adjust that. In order to do that, we'll take the dimmer all the way up, and then we'll take a screwdriver and we'll change the potentiometer on this volt regulator until it will be 10.5. 10 volts exactly. Because above it, this whole unit will be heated up so much, then it will be problematic. So this is the right voltage it can hold. So 10 volts from the 12 volt power supply, and again it will be getting 10 volts even from the 12 volt battery that will connect afterwards. Again, putting some strips so it will be nicely fit all the wires inside. And as I told you, again with our wonderful silicone, we're putting that on the back, so it will glue this volt regulator to the box so it won't jump around if this box will move. So we are also gluing the power supply to the box so it won't move. Again, using the same silicone that acts as insulation and also as a glue. Putting it in place, and of course tied up all the wires so we can close the lid afterwards. And we're closing it, and of course we have 4 screws to close as well, so it will be closed. And this is how it looks after we finish the job. Volt and 220 volt in and out for the LED panel. Okay, now it's time to test it, and when I tested I saw, oh no, there is 3 LEDs inside one of the strips which are dead. So what are we gonna do? Not a problem, we just mark them, and so we know where they are because it's very hard to find after that. And now we'll cut them out. And as I show you here, it's very easy to do. You just peel it up with a knife and then taking a cutter and cut this piece of real LED that doesn't work from this LED strip. And then of course we'll put a new one and solder them inside this line, and everything will work as you will see now. Now I would mention this is a step that I never saw in any video on YouTube. No one's giving you any input to what you're going to do when something like that happened. And as you see above this line, there is also a LED strip that are soldered inside, because the manufacturer himself, after they're testing it, figured out that there is a problem in 3 LEDs or so, and then they're of course cutting and replace them themselves with LED. So again, I cut a new one from a spare that we have that fits exactly this place. Before we connect them, I'm just taking 2 wires and try to feed them with electricity, so we'll see that they're working, and you can see it works. So very easily we peeled out the double face here, and of course putting our silicone in place. and everything left to do is just put them in place and solder them back to the line. Again, very easily an option to fix if this type of problem happened to you, even on build or even now, let's say, I don't know, after use. You don't need to replace the whole line, just every 3 LEDs has a separate resistor and so between them, so again, if one of them dies, you can just replace every 3, as you can see here, very easily, and then everything will work. So here you can see how easy it is to fix in case you get some LED that doesn't work. It's very easy, just cut it out and solder it back in, new set of LED, and you're ready to go. That's simple as that. And as you can see, it worked. Now we'll take 2 pieces of aluminium, 50 by 3 centimeter and thickness of about 1 or 2 millimeters, and we'll mark a triangle in each corner. After that, we'll cut it with a saw, and as you can see me doing here, and then in the end taking a plier and break the corner. Of course, we need to do it on all 4 sides of the 2 rows you see here. I'm only showing you once, but again, repeat the same step for all 4 corners. And then with the Dremel tool, I'm sanding the end so it won't be sharp, so it won't be easy to touch and nobody get hurt themselves from the edge corners. Now we'll measure the center of both, which is 25, as it's 50, so half of it's 25, and here is 3, so 2.5 centimeters is exactly in the middle. We'll mark it, and then we're going to drill it, and so in order for it not to move, I decided to invent something, just tied up the both ends with gloves, as you can see here. The gloves here are here to make sure that it doesn't move, and also when I clamp it with the plier, so it won't hurt the paint, so the paint won't be taken away from it because of the mouth of the plier. So the gloves doing 2 tasks here, one preventing it from moving and the other one preventing it from ruining the paint when I'm doing so. Of course, the next stage will be to drill it, so now since we want it to be accurate in the middle, we'll start with a 4mm drill bit and then make it larger with one which will be about 6.5mm, which will fit the hole that we need for this build. So as you see, I'm starting with a 4mm and then going forward to the 6.5. Now we can take the arm and put it in, and then take the nut from the other side and close it. After we do so, we can take out the gloves and everything and then put it inside our light. As you can see here, each corner going to a corner, each road. And when I did it, I didn't think that the whole thing is flexible and can easily bend it, so it will be easy to put it in. So at start it was very hard, and then eventually I thought to myself, why? The whole idea is it's very flexible, so instead of doing what I'm trying to do here to bend the aluminium, I can easily bend the whole LEDs and easily insert it. And as you can see, the next stage will be to connect the clamp arm to this unit. It's coming separate. It's when you buy it, you get both, and one is an option to mount it on a camera, so with a shoe mount, and the other one is this clamp that you can mount to anything. So this is the end product from the back. Now we'll take 2 gauge wire again and mark it on the ruler. In the end we need 1 meter, so I'm taking 60 plus 40, it's equal to 1 meter. Cut it out the line, and this line basically gives our power to the unit from the 12-volt battery. And we'll need to put, of course, the connector to fit the battery, and here I'm using a special clamp to close the wire on it. Of course, afterwards, I can solder it as well, so it will be very tight to the wire. You see, you just need this tool and 1 click and it fits the wire and doesn't go out. Next, I'm taking the solder paste and putting it here and also soldering it, so there won't be any chance that this wire will get out or move. Now we'll need to open the screw here. It's very gentle, so you need to find the right screwdriver for it. And then after you took it out, you need to turn this plug a bit to the left, and then it will come out. Now we'll take the 2 wires and put them inside this plug. And of course, taking our cutter and exposing the 2 wires, the positive and negative, soldering the end as we do with all wires. And now I needed to see which side is plus and which side is minus, so I connected the power supply to the electricity, and then when I start it up, of course it's giving power also to this plug. So this is how I was able to figure out which side I connected the minus and which side was the plus, instead of opening the box, of course, and see the wires inside. So this is how I did it, and here I also using this hand to hold this plug in order to solder it out, because otherwise it's moving and it's hard to do. When we done that, we just need to take the other end of the plug, close the top on it, and of course closing the screw that we just took out. And after that we'll close the 2 screws that holds the cable itself here in the end. Now we'll use the 12-volt battery you see here. I will do a separate movie of testing 4 or 5 brands of batteries to see which one holds the most. Although all of them have the same capacity, but of course we need to see in real life which one is better. So here is very simple task. We're just connecting the minus to the minus, the plus to the plus, and after that we'll connect the plug to our build and we can use it. So now it's being connected, and there is a ring here you can tie it up so it won't go out accidentally, and we'll give it a try. So we're starting with the daylight. As you can see, it works. And we also give it a try with the tungsten version as well, and it works as well. Thanks for watching my movie about this LED panel. Hope you enjoyed it. If you do, give it a thumbs up, and also think about subscribing to my channel so you'll get notified when I release my next movie. If you have any comments, please leave it below, and I'll be happy to help as much as I can. Bye!